Today's lesson is on graphing a quadratic equation in vertex form. Previously you learned about some basic characteristics of when we graph a quadratic. We will revisit some of those characteristics today. We'll revisit the vertex and the axis of symmetry. So vertex form is y equals a times the quantity x minus h squared plus k. It's important to note here that our vertex is located at h comma k. Notice this h is meant to be positive, this k is meant to be positive, but when you look at the actual equation, we do have a negative here. So when we talk about the actual vertex, we have to keep in mind that our h is intended to be positive when there is a negative present. So we're really going to take the opposite of that. Our k value here though is positive. So whatever k is at the end, if it's positive, it's meant to be positive. If there's a negative there, it's meant to be negative. So let's talk about what each of these three different variables that you see here, a, h, and k, represent. A is going to represent your vertical stretch. Now there's a couple of different things to note here. A can be bigger than 1, and if it's bigger than 1, then you're going to have a graph that is going to get, or what appears to be, narrower. You could also have when a is equal to 1, that's just going to be part of your parent function. You could have a situation where a is less than 1, so it would represent a fraction. If it is less than 1, your graph is going to appear wider. Or you can have the situation where a is going to be less than 0, so we're talking about a negative here, and that's just going to flip the graph upside down. Okay, it is important to know that if there is no number in front of the parentheses, that it is just a is equal to 1, and that's your normal graph. H is going to represent your horizontal translation. Remember, your horizontal translation is going to be movement in the left or right direction. And this horizontal translation is from the line x equals 0. Your k value here at the end is going to be your vertical translation. And that's going to be from the line y equals 0. So here we're talking about movement that is going to be up or down. So if it's going up, it will be positive. If it's going down, it will be negative. Going back to your horizontal translation, if we are shifting to the left, what's going to appear here is going to be a positive sign. And if you're moving to the right, it'll look like a negative sign there. So you really want to take the opposite. So let's do a couple of examples here together. Actually, before we do the example, it is important to note, and you want to make sure you get this in your notes, that your axis of symmetry is the line x equals h. Okay, so whatever your h value is here, that's what your axis of symmetry is going to be. So in example 1, it says the parent function is graphed below. Using the calculator, sketch a graph of the new function and describe how the graph of each function is related to the parent function y equals x squared. I don't actually have a calculator on me that I can bring up onto the screen. However, I can walk you through the steps that you need to do this by hand. So our normal vertex form is y equals a times x minus h, quantity squared, plus k at the end. Notice, Here I have a number in front of the x squared term. I don't have a minus h or a plus k. So this is your parent function. Just a couple points to notate: 0, 0, 1, 1, and 2, 4. And all parabolas are symmetric, so you can have the opposite in the left direction, so negative 1, 1, negative 2, positive 4. So that's your parent function. Now, if I go to graph this, again, we said that my a value is equal to negative 1. So if you pick some x values here using a table, if I say, okay, I want to check when x is 0, what do you get out y value? So if I put in 0 here, 0 times 0 is 0, and the opposite of 0 is just 0. So 0, 0 is still a point on this new graph. If I put in positive 1, 1 times 1 is 1, and if I take the opposite of that, I would get negative 1. So 1, negative 1 is a point. If I put in 2, 2 times 2 is 4. Opposite of 4 is negative 4, so 2, negative 4 is a point on this graph. And again, since this parabola is symmetric, that means negative 1, negative 1 is a point, and negative 2, negative 4. So this graph looks like the parent function, except it is flipped upside down. Okay, when I take a look at B, we're going to use that same philosophy that we did in this last one. We're going to take a couple of x values and a couple of y values, so 0, 1, and 2, and see what we get out when we put those x values into the function. So again, you see a number here in front. So this number here in front is going to multiply the x squared. There is nothing with the x, so there is no h value. There is no k value at the end. So my vertex, remember, vertex is h comma k. Since there is no h, there is no k, my vertex is going to be at 0, 0. So that brings me to my first point. When I put in 0, 0 times 0 is 0. Multiplied with 5 is still 0. So we can see that 0, 0 is still on this new graph. When I put in 1, 1 times 1 is 1, multiplied with 5. So 1, 5 is a point on this graph. When I put in 2, 2 times 2 is 4, 4 times 5 is 20. Our graph doesn't go all the way up to 20, it would be somewhere up here. However, the graph is symmetrical, so negative 1, positive 5 would also be a graph. So this graph actually got narrower because a was greater than 1, so that's why it is narrower. Okay, so how does it relate to the parent function? It's exactly the same thing, except it's going to increase faster because it's narrower. In the previous one, same as the parent function, it was just flipped upside down. So now when we look at this next one, here I got an a value that is less than 1, so this graph is actually going to get wider for us. So this parent function here, this next graph should be a little bit wider than what we see here. So again, if I pick some x and some y values, 0, 1, and 2, we'll pick another point here and I'll explain why in just a minute. But when I put in 0, 0 times 0 is 0, multiplied with 1/8 is still 0. So 0, 0 is a point. When I plug in 1, 1 times 1 is 1, multiplied with 1/8 is going to give me 1/8. Now this point is extremely difficult to graph on a graph like this, so you're kind of just guessing where it's at. So I'm not going to actually plot that point. When I put in 2, 2 times 2 is 4, 4 times 1/8 is 1/2, so 2 comma 1/2 is a point. It's a little bit easier to approximate. Now I'm going to choose one more point, but I'm going to do it strategically, and that next point is going to be 4. So 4 times 4 is 16. 16 times 1/8 is going to give me 8. Sorry, going to give me 2, not 8, going to give me 2. So 4 comma 2 is a point on this graph, and since it's symmetrical, negative 4 comma 2 is also a point. as well as -2, 1/2. So as you can see, this graph actually got wider. Notice not much else changed. The axis of symmetry, which was x equals 0, is still the same in all three graphs. And we didn't have any horizontal movement from the vertex or any vertical movement. So we'll take a look at the next couple of examples where we will start to see that. So just remember, when you have a number in front of the x squared, it's either going to make it narrower, like in B, or it's going to make it wider, like in C, or it can completely flip the graph upside down, like in A. So the change in the A value affects the graph by, well, when A is greater than 1, when A is less than 1, the graph widens. When A is greater than 1, the graph is going to appear narrower. And when A is less than 0, the graph is going to be flipped upside down. Alright, so D, E, and F. Okay, here notice in each of these problems there is no value in front of our x squared. So the graph is not going to get wider, narrower, or flip upside down for us. We don't have anything in parentheses. Remember, y equals a times x minus h squared plus k. And I don't have anything in parentheses in either of these three problems. However, I do have something after the x squared. Okay, so here's your x squared. I do have something after it. So here I have a plus 4. If we again choose points, since I don't have a graphing calculator, if I put in 0, 0 times 0 is 0, plus 4 gives me 4. So 0, 4 is a point on this graph. If I plug in 1, 1 times 1 is 1, plus 4 is 5, so 1, 5 is a point on this graph. If I plug in 2, 2 times 2 is 4, 4 plus 4 is 8, that would put me somewhere over here, but off the graph. So remember, it's symmetrical, so -1, 5 would also be a point. And notice what happened here. From my original vertex, my vertex has now shifted up 4 units. Again, if I talk about my h value, there is no h value. My k value is 4, so my vertex is 0, 4. Axis of symmetry is your h value, so axis of symmetry is going to be x equals 0. When I take a look at E, again, no a value here to flip the graph upside down, widen it, or narrow it. No h value on the inside, so h is equal to 0. My k value at the end here is -3. So I have a vertex at 0, -3. So now my vertex starts down here. And again, if I choose points, 0, 1, and 2, we already know that 0 is going to be -3 because 0 times 0 is 0. Minus 3 is -3. When I plug in 1, 1 times 1 is 1. Minus 3 is -2. So I have 1, -2, which also means I have -1, -2. And then 2 times 2 is 4. 4 minus 3 is 1. So at the point 2, 1 is another point. So -2, 1. And notice I still have that same shape that I have with my parent function here. However, it's just shifted down 3 units. Okay, so my translation is that it's shifted down because of this -3. Finally, in F, A is equal to 1. There is no h value, so h equals 0. My k value comes after the x squared term, that is plus 1. So my vertex is at 0, 1. So if I plot 0, 1, choose values for x and y, so 0, 1, and 2. 0 we already know is going to be at 1. 1 times 1 is 1, plus 1 is 2. So 1 comma 2, which also means that negative 1 comma 2 is a point. When I put in 2, 2 times 2 is 4. 4 plus 1 is 5, so 2 comma 5 is another point, which means negative 2 comma 5 is also a point. So when I go to graph this, I have that same shape as the parent function. I've just shifted up 1 unit. So again, anytime you have something after the x squared, that is going to shift your graph up or down. So the change in the k value, make that the k value, if you are shifting up, your number after the x squared is going to be positive, and if you are shifting down, the number after the x squared will be negative. So we've talked about what happens when a is a certain number. We've talked about what happens with k being a certain number. That's the one after the x squared. And the next one, we have stuff inside the parentheses, which is going to affect our h value. So again, no number out in front of a, so that's just normal. My h value here, remember, as I said at the beginning of this lesson, it's supposed to be negative, so y equals a times x minus h quantity squared plus k. It's supposed to be a negative here. So my h value is going to really be the opposite of this, which is positive 3. I have nothing after the squared term, like I do in the original, so my k value is going to be 0. So my vertex, which is h comma k, is 3 comma 0. So I'm going to start my vertex at 3 comma 0. So notice this one shifted to the right. Even though it was negative here, it shifted to the right. So now if I choose other values for x and for y, for x, 0 we know is going to be 3. If I put in 1, 1 minus 3 is negative 2. Negative 2 times negative 2 is going to be positive 4. So when I put in 1, I get out 4. Now, since your vertex has shifted, you are 2 units away here and you got out 4. I'm not going to pick negative 1 because that would be increasing even more when I go to the left. So I'm going to go 2 to the right, but then it's also going to be up 4. So that's actually a point 5 comma 4. Okay, so now when I put in 2, 2 minus 3 is negative 1. Negative 1 times negative 1 times negative 1 is positive 1. So 2 comma 1 is also a point, which means if I'm 1 to the left and up 1, I'm going to go 1 to the right and up 1. So my graph looks like that. Again, if I compare that to the parent function, I have a point at 1, 1, which is 1 to the right of the vertex and up 1, 1 to the right of the vertex and up 1, 1 to the left of the vertex and up 1, 1 to the left of the vertex and up 1. So it kind of follows that similar pattern that we have going on there. Okay, looking at the next one. Okay, here I have a plus 2 on the inside, no a value, or a is 1, so that's normal, and no k value at the end. So h is going to actually be the opposite of positive 2, which is negative 2. So that means that our graph is going to be shifted to the left 2 when I think about my vertex. So negative 2, k value is 0. So I have a vertex at negative 2, 0. So if I pick values for x and for y, I'm actually going to start this time with my vertex at -2, 0. And then I'm going to pick points that are to the left, so 2 points to the left or 2 points to the right. So I'll go 2 points to the left, so that's -3. When I put in -3, -3 plus 2 is -1. -1 times -1 is 1, so -3, 1. When I put in -4, -4 plus 2 is -2. -2 times -2 is +4, so -4, 4. So let me get rid of this real quick so you can see that last point. And then it's symmetric, so left 1, up 1. Let's go right 1, up 1. Left 2, up 4. Right 2, up 4. So this is what my graph looks like. So this graph is shifted 2 units to the left. Okay, so if you've been following along, if it was +2, we shifted 2 to the left. If it was -3, we shifted 3 to the right. Since this is -1, that looks kind of like this problem here. So this one's actually going to be shifted to the right 1 unit. So my h value is +1. My k value is 0. So that means my vertex is at 1, 0. If I choose values for x, we know that 1, 0 is already one of our points. So I'm going to pick 2 and 3. When I put in 2, 2 minus 1 is 1. 1 times 1 is 1. So 2, 1, which then means that 0, 1 is also a point. When I put in 3, 3 minus 1 is 2. 2 times 2 is 4. So 3, 4 is a point, which means that -1, 4 will be a point to keep it symmetric. So this graph is shifted to the right 1 unit compared to the parent function. So the change in the h value affects the graph by, if your h value inside the parentheses is negative, it's going to shift it to the right. So I'm going to put in parentheses that if it's negative, it'll shift it to the right. And if your h value inside of the parentheses is positive, it's actually going to shift it to the left. Alright, example number 2. Here it says describe the transformation that would result in the graph based on the given function, then identify the vertex and the axis of symmetry from the equation. So when I look at this first example, A, I have y equals negative times the quantity x minus 3 squared plus 4. So I have a couple different things going on here. My A value is -1. Remember, if it's negative, that means that the graph is going to be flipped upside down. And here I have an h value. Now, don't get confused that it's a negative here because it's supposed to be negative. Remember, y equals a times x minus h quantity squared plus k. So since it's supposed to be a negative, and that is negative, my h value is 3. So that means that the graph is going to be shifted to the right 3 units. And my k value here at the end is supposed to be positive in the original function. So k is equal to 4 here. So that means it's going to be shifted up 4 units. So my vertex, remember, vertex is h, k. So my vertex is at 3, 4. And remember that your axis of symmetry is the line x equals h. So since h is 3 here, my axis of symmetry is going to be x equals 3. In B, notice there is no a value shown, so a must be 1. So just like the parent function, my h value, in this case it's positive 2. It's supposed to be a negative, so that means if I take the opposite of that, it's going to be -2, which means it's going to be shifted left 2 units. My k value is here is -3, so that means that we are shifting down 3 units. So my vertex is located at -2, -3, and my axis of symmetry is x equals h, which in this case is -2. In C, my a value is -2. So that means that not only is the graph going to be flipped, but the graph is also going to get narrower. Okay, my h value, well, there is nothing in the parentheses with x, so my h is 0. My k value is +4 on the outside, so that means that it is getting shifted up 4 units. Vertex is located at 0, 4, and my axis of symmetry is the line x equals 0. Now what I'd like you to do is the U-try, A, B, and C. So go ahead and pause the video. When you're ready to resume, unpause and check your solutions. Alright, for A, you should have gotten A is equal to 1/3, so that's actually going to make the graph a little wider than the parent function. Your h value is -7 because it's plus on the inside, so that's shifting left 7 units. Your k value, there is nothing after the parentheses here, so there is no shift. So your vertex is at -7, 0, and your axis of symmetry is x equals -7. For B, your a value is -1, so that means that it's flipped upside down. Your h value is going to be the opposite of this number, so that's +5, so we're shifting it right 5. Your k value is +1, so that means that we're shifting it up 1. Vertex of 5, 1. Axis of symmetry is x equals 5. In C, a is equal to 1, so there is no number in front of the parentheses, so that's just normal like the parent function. Your h value is going to be the opposite of this, so that's 4. Your k value is the same as this, so that's 2. So we're shifting right 4 and up 2. Vertex of 4, 2. Axis of symmetry is x equals 4. This concludes the lesson on graphing quadratics in vertex form.